Good morning, student. Architecture 110. Today we will discuss about the earthquake, the issues concerned with architects, because earthquakes sometimes happen in some building effect on that one. So that's why we need to know a little bit about that better before you design in somewhere they have many concern with the earthquake. Really, in my life, I say I'm stay in California since 1990, and at that time I hear a lot of people talk about the earthquake in this state, California. But until now, I'm stay in California almost 30 years, and I think that yes, it is. They have maybe one or few earthquake a year, but the most thing is around 7 point, and the last of them, I mean, we have many earthquakes around 5 point, 4.5, something around that, or 6 point. That is normal. So that's why with me, the earthquake, it is something, it disaster. We cannot do anything except we need to know some kind like help us to protect at that time. So you see, not US, a lot of people in the world, they need to have the earthquake, and usually the earthquake coming, and after that tsunami. Two of them be disaster, and it can destroy a lot of lives in the short time. For example, in Japan, 2011, you can see that tsunami, it happened. It just can, destroy a lot of things, a lot of house, area, people in that case. So that's why not just US, a lot of countries, Japan, Mexico, South America, and another country, Nepal. So that's why it's happened anywhere, not just US, not just California. This is some picture you can see that's at Italy, Europe, in 2016 August. You can see that's after the earthquake happened. You can see that's all of the house is destroyed by that one. So that's why, because our major architecture, so beside of the cost for material, before we start to do with a design, the disaster is some of the factor we cannot control. That it's happened anywhere, anytime. This is tsunami. Can you see that whole big area is become like that? And this is the booth. You can see that it's on the top of the building, because it's come out to the tsunami, come out to the sea, and after that it come in the land, and you can see that's how much damage from one of tsunami. Destroy everything after that one. This is another Nepal, 2015, and you can see like that after the earthquake, and you can see all of the building or the house can be damaged, so damaged. China, Japan, China 2009. You look at this. This is, I guess it's a temple, and all of them, and this is the mountain freeway. You can see that all of the collapse. And this one in the Kobe, Japan, is, you can see that this is the wall separate between. They have protect in the country. They have many wall like this for make sure that they can protect area to area during the time the earthquake, and you can see like this. So Japan is, I think that Japan is the country, they have many earthquake a year, and they have many big ones, tsunami also. Even they have the small country, and this is the island country, but it's so much, many times happen with the big earthquake or tsunami. Okay, so now we need to go with a little bit about, you should know about the earthquake, like a student architecture major. Earthquake earning warning. Usually, if you look at the people, they say EEW in the news. That means they warning about earthquake, early warning. They warning about the earthquake coming soon. So that's why with this one, you can at least you can ready something before earthquake coming. And this is the system they use for the earthquake science and technology. They monitor the system for the alert device and the people when shaking wave generated by earthquake, and they are expect arrive in their location. So they give you the time, and they have announced for everywhere close with that area. In the second to minutes of advance warnings, it can allow the people, in the system take the action. You can protect the life, and you can make the property from the destructive shaking. So even few minutes, few seconds, but at least it will coming. So you're ready, and you can help, or you can stop, or you can do something. Is so danger when the earthquake coming. You can decide at that moment. In the public, you can see the citizen, school for children, develop, cover, turn off the stove, safety, stop vehicle, because at that time it's shaking, so vehicle cannot control even you on that. So that's why it should be stopped and breaking up. In the business, and personnel can move to safe location. If you have the time, move to the area we noted before. Automatic system ensure elevator door open, because at that time maybe they shut down from electrical, so that's why it should be everything open, and production line are shut down. Sensitive equipment in the place in the safe, we need to do that one in the safe mode. For the medical service, for example, the surgeons or dentists or other, we need to stop delicate procedure. In case it's shaking, you cannot do exactly or correctly the treatment. Emergency responder open the firehouse door, repair and prioritize response for decision. So you need to do that. In the power infrastructure, you need to protect the power station. That's special, because if the power station is got damaged, and whole of that area will be lost the control, and the read from facility from the strong shake. So basically, EEW system are currently operate in the several countries, and other are built down. 2006, the US GS, they have working to develop for earthquake early warning for the United States, with the have several cooperating organizations include California Geological Survey, GSC, the California Institute for Technology, Cal State, California Office of Emergency Service, CalOES, the Moore Foundation, the Southern California Earthquake Center, SCC. This will be included on key number 3, fill in the blank. In the Swiss Federal Institute for Technology, Zurich, the University of California, Berkeley, and the University of Washington, they have the EEW. The goal to recreate and operate for EEW system for the highest risk area from California, beginning with the West Coast state. The West Coast state included California, Washington, and Oregon. So that's the system should be begin on there, because that's the highest risk from the U.S. Earthquake earning warning around the world. That's we just discussed about U.S. Now how about the world? Strong seismic shaking from the earthquake travels at about 2 miles per second. It's so strong, so fast. So it is possible to detect a large earthquake near its source and broadcast a warning. Imminent strong shaking to more distant area before the shaking arrives. The system are operation in several countries around the world, includes Mexico, Japan, Turkey, Romania, China, Italy, and Taiwan. All of these systems are tailor-made for local system of the fault and thus cannot readily adapt in California because it's still on the system and they have the fault. So that's why it's not ready for adapt in California. That means the system from the around the world. Okay, USGC usually have the meeting and will discuss about the warning EEW for all of the people in the United States and the organization to concern with the earthquake. Now, if you go with the earthquake, you need to know few basics number show one the earthquakes is. First of all, you need to know the real-time tracking of the seismic wave from wake of epicenter. Number one is around S wave and P wave. So number one is the real-time tracking from the seismic wave. What time they will come in. Number two, in the center, it's the real-time track of the force crater update intensity. This is the point from the earthquake. Number three, right here, is your current location tracked by GPS. This is the location and you'll be tracked by UBS. Number four, that is the second remain before seismic wave reach you. That means the wave here come with you. How long? For example, we say 28. That means they're coming at 28 seconds. Remember, seconds. Number five, expect intensity of the wave at your current location. That means velocity, intensity from the wave is come to your area. Number six, estimate magnitude from the quake. That's the point. Usually you hear about earthquake 7.8, earthquake 5 point, something like that. It's the estimate from magnitude from the quake. That means how big from the quake. And last one, number seven, intensity scale. This is the scale they use to measure the intensity. So basically, on each of the earthquake, you need to know this number. The first one is the real-time tracking from the wave. The second one is the real-time tracking to the force crater at that one. And number three is the current lower when you got the GPS. Number four is the distance, how long by second remain before the wave coming. And after that, number four, number six is a magnitude from the quake, the intensity from the scale, and the quake for the current area. So basically, you should know that one. So now, example from the early warning system. In the Mexico City, they have early warning system. That's one of strong shaking from large earthquake that's occurred. Let me see, hang on. So earthquake early system in the Mexico City, the one is strong shake from the large earthquake that occurred up on the country coast. The system consists of a series of the sensor located along with the coast and detect shaking. You will see the picture later. It shake from the large earthquake and they rapidly determine the location and magnitude. In Mexico City is located several hundred miles from the main place boundary. They can receive up to the minute or more of the warning in the pattern shaking. The system has been operated in 1991. Japan is currently had the most sophisticated early warning system in the world. So because they have a lot of earthquake every year, so that's why the system they have is so current in the world. The warnings were initially developed for use of slowing and stop the high-speed strain prior to the strong shaking. The warning just make sure that you develop for the use for the slowing, stopping the high-speed strain for the shaking. This is the map or the graph you can see for the distance to the earthquakes and epicenter is per mile. 70 miles is the top one. It's so fast. And it is for this is the second, and you can see that assume 10 seconds to issue warning. Okay, so when you hear the earthquakes, it just go like this. For example, the point they happen the earthquake and they go in the ground circle. You can see that the unit is second. It's so fast, so strong and so fast. So that's why they use the unit in the second. You see that's 0 second, 6 second, 12 second, 18 second. You look at the distance like that on the map, it's so far, but they go like this, and it can happen so fast. You can see that 1 minute, and how far from the point earthquake to shaking from around area. So you can see that so fast, and they say that kilometer 100 from here to here 100, and you can see that how many hundred for 1 second. So that's why it's so fast. The success of the program, in addition to devastating effect on 1995 Kobe earthquake, they have paved the way for the building a nationwide early warning system after that. Japan had built a dense network of on-shore seismics and geodetics instruments to rapidly detect earthquakes. They have been issued public warning since 2007, very early. This is something you can understand more about the earthquake. They have 3 stages. So the first one, they usually crack epicenter, and they have the force right here. After that, they go with the S-wave. The S-wave first, and the second one, they go with the second one, the P-wave. When the P-wave, they hit with the sensor, and the sensor go with the earthquake alert center. And after that, they go to the sensor position about 6 to 12 miles apart. So that's why if you look at the sensor like this, it has 6 to 12 miles apart. Basically, when the earthquake coming, the first one you can see the S-wave. S-wave tell you this is the earthquake, and the P-wave coming very soon later. They said, okay, warning coming, and they said in the sensor, they hit in the sensor, and the sensor go with the earthquake alert center. That's the center go everywhere, and they will announce that will be have the alerts coming in 6 to 12 miles apart from the sensor. This is, you can see that it's from 6 to 12 miles from one sensor. They have like this, but it's so fast, so that's why everything we need ready. This is some a big city on Mexico, and this one from Mexico, Osaka, after one earthquake happened. Usually after the earthquake, the one we so scared it is the fire coming, because the rocking and the hot and everything, you know, can be fire easily. So basically when you see one earthquake and the continue with that, it's in one of the big fire after that. Okay, so that's it for the chapter for today. Earthquakes happen everywhere, especially when you live in California. You need to thinking about that. This can happen anytime. And if you look at the map, we on the rack as of the south from LA until San Diego and New Mexico. The Mexico. So basically we live in the change, can be have the earthquake anytime. So many people advise that you need to ready for your house at least for 10 days. No electrical, no water, no food, and ready everything in case it happened. And we know the way how to protect yourself and wait for another people can coming to save us. So thank you so much for watching this video, and see you next time.